Hello YouTube, this is the final test with everything in place of my multi-band low pass filter board. So this is the low pass filter board. I left some space for future 160 meter band filter. So this is currently this is 80 meter band, so that will be the default filter without any delays activated. And this is 40 meter, 20, 15 and 10. They are actually shared with other work bands. And looking through the components here quickly, this is the main TR relay, and from input this is 7 dB attenuator, and this is additional 2 dB attenuator switched in with this toggle switch, so it can be total 9 or only 7 depending on the switch position. And this is the main PCB for this linear amplifier. The MRF101 is below this hole, and this is the relay board with 5 volt power supply for these two chips. And this relay is for next stage amplifier. In my case it will be a kilowatt linear amplifier. And this NAND gate IC is used to make a OR gate, so it will be this BIOS cutoff will be cut off depending on PTT input. This is PTT in from transmitter, and there is also another signal coming in for overcurrent alert, overcurrent alarm. So with these two input OR, it will cut bias of this final. So when bias current is supplied only with PTT on, PTT input relay on, and no overcurrent alarm. And overcurrent alarm is coming from this separate board. Inside I have STM32 microcontroller, and there is actually a current sensor INA169 to detect current consumption. Is somewhere here behind. And this one is for 12 volt power. So from 50 volt in, it's a DC-DC converter to supply 12 volt to the microcontroller and the next stage, this relay board. So the 12 volt from there will be supplied to this 5 volt regulator and all these relays. So 5 volt regulator supplies power to these two ICs. So let's check each band's plot. Oh, I forgot to mention, this microcontroller also receive serial port data from HL2, and it will choose which relay depending on the frequency input from HL2. So if I move any frequency from here, so like current frequency is 28.5, so it detects the frequency data from HL2 and choose this band, 10 meter to 12 meter band, and the proper relay is turned on. In this case, for 10 meter band, these two relays get turned on. So let's check. For 10 meter band, we'll check with this calibration. This is from 18 to 60. Oh, that's strange. So I go to 20, come back to 10. Yeah. So this must be it. So cutoff frequency is around here, 29, around 30 megahertz. I already see loss increasing from 0.2 to 0.6 at around 30, a little bit over 30 megahertz, and 3 dB down at around 42 megahertz. So at the second harmonics of 10 meter, it's around 25 dB. Yeah, this 10 meter band design, low pass filter design, is from GQRP club. So this one is not quite sharp. It's not very steep. But for all other bands, I chose other design which has steeper graph. So if I change the band to 15 meter band, yeah, I see 15 meter band here. So 3 dB around 26, and at 21 megahertz I see good numbers here. So this is 15 meter band, and for 20 meter band, so maybe I should change the frequency range. This one. Yeah, so this is for 20 meter band. This is no, 20, yeah, 20 meter band. So at 14 and for 28 second harmonics is about this. Yeah, and now switch to 40 meter band. Meter band. Yeah, this one would be yeah, this is 7.2 megahertz. So all these details had been checked in my previous video for each band. So I'm just making sure the band switching is working alright. Now the final band, 80 meter band. 80, 160, there is no switching. The relay ticking is for high pass filter inside HL2, but for this linear amplifier, no relay is ticking. This is 40, this is 80 meter band. So for 80 meter band, this might be good. Yeah, this is 80 meter band plot. And .8 megahertz, 3.7, 3.5. Right? So 80 meter band doesn't share with any other band. second harmonics at 7 megahertz. Is about minus 40 dB. Oh, 80 meter band actually share. Oh no, does not share any with any other band. 40 meter band shares with the 60 meter band also. 60 meter band. Is somewhere 8 point, 6 point, no, 5.3 megahertz. 5.3 megahertz, somewhere here, right? SWR must be a little bit higher than other bands. Okay, so everything is working fine. Every time I click on other bands, I see relays ticking for the proper band. Right? So that's it for today.